Next section now, we are on cylinders and spheres. We're going to work on volume and surface area once again. Okay, so for cylinders, volume, you can remember the same formula we used for prisms. Exact same formula, area of the base times the height. So for a cylinder like this, the base is a circle. So it's pi r squared times h. That's the equation for the volume of a cylinder. For surface area is 2 pi r squared because the area of these two circular faces. And then the lateral area is 2 pi r h. So 2 pi r squared plus 2 pi r h. I feel like that doesn't come up as often. So you should memorize it, but if you want to prioritize memorizing one of the two formulas, memorize the volume. Okay? And for spheres, you should memorize both the volume and surface area formulas. This comes up in calculus a lot if you're going to take calculus. For volume, it's 4/3 pi r cubed. Okay? And then surface area is 4 pi r squared. And why it comes up in calculus is if you differentiate the equation for the volume of a sphere with respect to the radius, it's the surface area formula. So that's an important calculus topic, actually. But this is not calculus right now, so we're not going to dive into that. So those are the formulas you need to know. And now let's go on with the problems, all right? Number 1, in the figure above, a sphere is inscribed in a cylinder so that the diameter of the sphere is the same as the diameter of the cylinder and the height of the cylinder. Okay? The diameter of the cylinder and the height of the cylinder. What is the value of volume of sphere over volume of cylinder? Okay, so what's the volume of the sphere? Volume of the sphere is 4/3 pi r cubed. Let's write that, okay? Volume of the cylinder, area of the base times the height. So, what's the area of the base? It's pi r squared. It's the same radius, right? This is the radius of the sphere, which is also the radius of the cylinder. What's the height? Well, it said that the diameter of the sphere is the same as the height of the cylinder. So the height is 2r. Area of the base times the height. Okay, so let's start simplifying. The r cubes would cancel. The pi's would cancel. So we have 4/3 times half. This is a 2 on top, so that's 2/3. Answer is B. Let me double check. Yes. Okay. No real numerical calculation needed, actually, for that. Let me zoom out a little bit as well. Okay. The figure above shows the mechanical part in the shape of a steel cylinder, 8 inches high and 6 inches long in diameter. A hole with a diameter of 3 inches is drilled through the mechanical part. The density of steel is 490 pounds per feet cubed. What is the mass of the mechanical part to the nearest pound? Okay, so this is similar to the other problems we did in the prism section. So let's find, the hint is this density, mass over volume. So let's find the volume of this guy first. So the volume is, well, what's the volume of the big cylinder? It is pi r squared h, right? Area of the base times the height. So pi, what's radius of the big cylinder? That is 3, right? 3 squared times the height, which is 8, minus the area of this hole, which is also this hole, which is a cylinder shape as well. So pi r is 3/2 squared, and the height is, again, 8. Okay, so what is this now? We can factor out the 8 pi. 9 minus 9/4. Okay, so what is that? That is 36/4 minus 9. That's 25/4, so 8 pi 25/4, okay, which is 100 pi. Okay, so the volume of this guy is 100 pi. actually that's not matching my previous answer, so let me check what I did wrong, unless I did it wrong previously. Let's see. I see what I did. This is 27, okay? So then this is 54, okay? So that the volume of this guy. So now we want 54 pi. This is what, in feet cubed? Or inches cubed, sorry. Inches cubed. You got to be careful because this is in pounds per feet cubed. So we got to use that it's 1 foot divided by 12 inches. But you need to do this 3 times because this is inches cubed. So cube that, cube that, cube that, cube that. Okay? So the inches cubed would cancel. So now we can multiply by that density times. This is 490 pounds per feet cubed. So this is 490 pounds per feet cubed. Gotta make the units work out. So, whoops. Okay, let me write it over here. 490 pounds per feet cubed. Okay, the feet cubed would cancel. So what is this? This is 54 divided, whoops, I'm plugging into my calculator right now, by the way. This is 54 divided by 12 cubed, and then times 490. Typed it wrong, have 490. This is 15.3125 pi pounds. Again, this is not mass, this is weight. So this times pi is about 48 pounds. So the answer should be C. So apologize for the mess over here, but hopefully, again, like I did in the other problems, units, they help out a lot to make sure you're on the right track. Like here, I accidentally flipped it, and then I clearly saw the units didn't work out. Okay. Next, figure above shows 2 cylinders. The height of cylinder 1 is twice the height of cylinder 2, and the radius of cylinder 2 is twice the radius of cylinder 1. The volume of cylinder 1 is 45 pi inches cubed. What is the volume of cylinder 2 in cubic inches? Okay. So we probably have to do something a little symbolic over here. Volume of cylinder 1, 45 pi inches cubed. Pi r squared h, area to base times the height, is the volume of the cylinder, right? So pi for cylinder 1, what's r? It's just r. So r squared. What's the height? It's 2h. Okay? And then volume of 2, let's say volume 1. Volume 2 of cylinder 2 is pi times 2r, quantity squared, times h. So this is 4 pi r squared h. We probably need to get 4 pi r squared h somewhere over here. Okay? So how can we do that? Well, let us, 45 pi is 2 pi r squared h. Okay, so I just move that 2 out there. Now I just need to multiply 2 on both sides, right? So 90 pi is 4 pi r squared h, which this is V2. So that's why I said we had to do things a little symbolically. So the answer should be D, 90 pi. Okay, pretty simple. Hopefully if you were able to see that. Now this one. In the cylindrical tube shown above, the height of the tube is 30, and the circumference of the circular base is 32. And the tube is cut along AB and laid out flat to make a rectangle. What is the length of AC to the nearest whole number? So we want this diagonal AC, right? So we probably need AD. And we can use the Pythagorean theorem, so I'm thinking right away. This is a rectangle, I said that, right? So what's AD? How do we get that? Well, the circumference is 2 pi r is 32. Okay, so r is 32 over 2 pi, which is 16 over pi. And this is there's no units here. So 16 over pi. That's the radius, okay? So AD by the way, we have, this is pi d for diameter. So diameter is 32 over pi. Okay, because we would multiply the radius back by 2 to get the diameter, right? So AD is 32 pi. So sometimes it's helpful to know that diameter, circumference is pi d instead of 2 pi r. Okay, so this is 32 pi, 32 over pi. Okay, now we can find AC by the Pythagorean theorem, right? That's the hypotenuse. So 32 over pi quantity squared plus 30 squared is AC squared. So let's for sure need a calculator. Okay, so if we plug it in, AC would be 31.682, something like that. So to the nearest whole number, it should be 32. But there's no choice here. So I think this problem messed up on some numbers over here. But AC should be 32. This is the answer I got previously as well. Okay? So no answer, I'm not going to circle anything, but it should be around 32. This is how you find AC. Okay, that's it for this video. Hopefully this is helpful. Please like and subscribe if you found this helpful in any way. And I believe next is the last section before the review. And it's on pyramids and cones. So we're going to go over surface area and volume of that in the next video. Hopefully I'll see you there.